All right, the first thing you want to graph, first thing you want to locate is the center point. So to locate the center point, we're looking at our quantities up here. I see nothing is added to 0, or I'm sorry, nothing is being added to x, or nothing's being added to y, so my center is just going to be the origin. Now, since this is the first problem we're doing, as I find information over here, I'm going to go ahead and plot it on the graph. Got my center point for my ellipse located at the origin. Okay, next thing I'm going to figure out, I'm going to figure out the length of the x radius. To figure that length out, all I got to do is go back to the equation, locate where my x's are at, look at the value that's underneath those x's, take the square root of that value. So my x radius here is going to be 5. Now that means from my center point here, since this is an x radius, I can travel horizontally 5 units in each direction. 1, 2, 3, 4, 5, plot a point. 1, 2, 3, 4, 5, plot a point. All right, next component we find is the y radius. Find the y radius, very similar to finding the x radius. The y radius, look at the y stuff. Underneath the y's here, I've got a 4, so I'm going to take the square root of 4, which is 2. That gives me the vertical direction I want to travel from the center. So here's the center. I'm going to go up 2, plot a point, down 2, plot a point. And at this point, I can come up with a reasonable sketch of my ellipse. But because focal points are important to being able to determine this curve, I do want to acknowledge the focal points as well. Now, the focal points will lie on the major axis. The major axis is going to be located right here, right? It's going to be the horizontal one. So to figure out the focal points, we'll let C represent that distance that I have to travel from the center to get those focal points. C is going to equal the square root of, well, I'm going to take my larger value minus my smaller value represented up here in the denominators, get the square root of 21, simplify roots where possible, can't do much better than the square root of 21. Now it's just a matter of applying the square root of 21 as a distance. So reasonable approximation for the square root of 21, greater than 4, less than 5, right? So from the center point, I count out 1, 2, 3, 4 along the major axis. It's a little past 4, a little less than 5, plot a point. And then same thing heading the other direction. 1, 2, 3, 4, a little past 4, less than 5, plot a point. There are my foci. All right, so graphing this one, starting the same way as the last one. Locate your center point. To locate my center point, it's going to look at the quantity squares located in the numerator. For the x-coordinate of that center point, I know it's going to be -2, since it's x plus 2. For the y-coordinate of that center point, I know it's going to be -1, since it's y plus 1. Found the point -2, -1. Let's go ahead and plot that. Now let's look at the x radius. To determine the x radius, locate your x's up here. Let's see what's underneath the x's. You got a 4, so you're taking the square root of 4. X radius is 2. So from our center point, we're going to travel horizontally 2 units in each direction. Now find the y radius. Locate the y's up in the equation. Look to see what's underneath those y's. In this case, a 9. Take the square root of that 9, giving me a y radius of 3. So from my center point, I'm going to travel vertically for the y radius, 3 units in each direction. Now I can draw a reasonable sketch of the ellipse. Just like the last one, I want to acknowledge the focal points as well. So if we let C represent that distance for our focal radius, C is going to equal the square root of, just taking my denominators here, taking the large one, subtracting the small one, be 9 minus 4, get the square root of 5. If I approximate the distance for the square root of 5, it's going to be greater than 2, less than 3, right? So I'm going to travel out that distance from the center along the major axis. So notice on this one, the major axis is vertical. The last one, the major axis was horizontal. So major axis, the longer one, from the center point, I'm traveling out the square root of 5, a little longer than 2 units. I'm doing that in both directions. Blue points represent my foci. That's a reasonable sketch of the ellipse. So yeah, kind of like we use with our circle approach, we want to complete the square, so we're going to group our x's. At 25x squared plus 100x, leave a little space. Got a plus 9y squared plus 18y, leave a little space. Got a constant of 116 we're going to add over to the other side. Alright, if we're looking to complete the square, this is a little different than with the circles. The big difference is, notice the coefficients on the quadratic terms. We don't have ones. If we're going to be able to complete the square, we need ones. So for the x's here, I'm going to take out a 25. I'm going to have x squared plus, I'm factoring out a 25 from 100, so that's going to be 4x. Leave a little space. And over here, with the y's, I got that 9 sitting there. I want to take the 9 out. Got y squared plus 2y. Leave a little space. All that equals 116. So, completing the square. For the x's over here, I'm going to take half of the 4, which is 2, square that, which is 4, and add that on. Now, by adding on 4, remember with the circles how we had to balance out each side. I would have added on 4 over here. But this 25 does impact what you're doing with that 4. So what should I add on over here? 100, because that's 25 times 4. And then for this one here, with the y's, I'm going to divide by 2, 1, square that, still 1, add 1 on. Alright, looks like I'm adding on 1 to change the value of this side, but I'm not really adding on 1. I need to add on what to the other side? 9, because it's 9 times 1. Right, this 9 impacts that 1. So we clean this up. Got a 25 in front of our perfect square. The x squared plus 4x plus 4 factors down to x plus 2. Plus, got 9 in front of this perfect square, which is y plus 1. That's what y squared plus 2y plus 1 factors down to. We add our 116, our 100, our 9. Let's see, that gives us 225. Okay, we're almost there. If we're trying to get to our form for an ellipse, though, we want an elliptical equation. What do we need to have everything equal to? Everything has to equal 1, doesn't it? So, it'd be real nice if I had 1 over here. To make that happen, I can divide by 225. So here I divide by 225. Here I divide by 225. And since I got some factors, 25 and 9, I'll be able to do some reducing here as I go. I'll have a quantity of x plus 2 squared. That's going to be over 225 basically divided by 25, right? Since the common factor of 25 is shared between these two. So that's going to be 9 down here. Plus, got a quantity of y plus 1 squared. So common factor of 9 shared between 9, obviously, and 225. That's going to be 25. All that equals 1. And now we're finally at that point where we started on the previous problems. Since we're finally at that point, we can figure out what the center is. What's the center going to be? -2, -1. Right, just switch your signs on these. -2, -1. For our x radius, we've got a 9 under the x quantity, so take the square root of that 9, get 3. We're going to travel horizontally 3 units in each direction from the center. Y radius, got your y quantity here, 25 is underneath that, so you take the square root of 25, which is 5. Vertically from the center, we'll travel 5 units in each direction, so 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. At this point, we draw a reasonable sketch of the ellipse, understanding we still have to find those focal points. So, to find those focal points, we let C represent that distance. Those focal points are represented, or I'm sorry, they are from the center. C is going to equal the square root of, looking at my denominators here of 25 and 9, take larger one, subtract smaller one. C is going to be the square root of 16, so C is going to be 4. Along the major axis then, which is the vertical axis this time, from the center point I'll travel out 4 in each direction to plot my foci.